We all remember the periodic table from school, right? That big, colorful chart on the classroom wall. But what if I told you it's less of a chart and more of, well, a treasure map? A map that tells a story of a scientific photo finish, a wild prophecy, and a glimpse into the future by a chemist who could literally see what wasn't even there yet. Okay, let's get into it. To really appreciate the genius behind the table, you have to picture the world back in the 1860s. Chemistry was kind of stuck, facing this massive challenge that was holding almost all progress back. And when I say chaos, I mean complete chaos. Imagine trying to build a library, but you don't have an alphabet, or trying to understand a language without any grammar. That's pretty much the brick wall chemists were hitting. At that point in time, they knew of exactly 63 elements, and each one was like its own individual puzzle piece. They had all this data on them, but zero clue how they connected to each other. It was a puzzle without the picture on the box. This family of elements was just all over the place. You had these super light gases like hydrogen, and then these heavy, dense metals like lead. Some elements would practically explode if you looked at them wrong, while others were so chill they wouldn't react with anything. There was no rhyme or reason. What chemistry needed, desperately, was someone to bring some order to the chaos. But this hunt for order wasn't a solo mission. In fact, the story we usually hear, the lone genius having a eureka moment, is a bit more complicated. And honestly, it's way more interesting. The race was on. All across Europe, the smartest people in the field were trying to crack this elemental code. And as it turns out, two different chemists, working completely on their own, were about to have the exact same brilliant idea at the exact same time. So on one side, you've got Dmitri Mendeleev over in Russia. He's totally obsessed with how elements react with each other. And on the other, you've got Julius Lothar Meyer in Germany, who's more focused on their physical traits, like size and weight. And here's the wild part. Both of them, totally separately, arranged the elements by atomic weight and saw the very same repeating periodic pattern emerge. It was a true scientific dead heat. They basically crossed the finish line together, which kicked off this debate among historians that's been going on for over a century about who really deserves the credit. So, if it was a tie, why do we really only remember one of their names? Well, this is where the story gets really good, and where we see that spark of true genius that set one of them apart from everyone else. I mean, that's the big question, isn't it? Meyer saw the pattern, Mendeleev saw the pattern, so why is it Mendeleev's table hanging in every single chemistry classroom in the world? And here's the key. Mendeleev's real breakthrough wasn't just arranging the puzzle pieces he had. It was having the incredible guts to draw the shape of the pieces that were still missing from the box. The story goes that Mendeleev basically played a game of chemical solitaire. He wrote down all the properties of those 63 known elements on individual cards. He'd lay them out, shuffle them around, looking for that hidden rule. But when an element just didn't quite fit the pattern, he didn't try to force it. He did something incredibly bold. He just left a blank space. He said, there's an element that goes here, we just haven't found it yet. And this part is just mind-blowing. He didn't just leave gaps. He made incredibly detailed predictions about what those missing elements would be like. He called one ecosilicon and described its weight, its color, its properties, everything. Years later, an element called germanium was discovered, and boom, it was a perfect match. He did the same thing for gallium and scandium. This wasn't just organizing anymore, it was prophecy. And it proved his table wasn't just a convenient chart, it was a fundamental law of nature. That predictive power is what sealed the deal for his legacy. But the scientific community gave him one last, ultimate honor, a permanent home right on the very map that he created. So let's look at the table and go way, way down to element number 101. It's a highly unstable, man-made element that would become the ultimate tribute. Meet Mendeleevium. It was created in a lab back in 1955, and the scientists who made it decided to name it to honor the guy who first understood the periodic law. I mean, to have an element named after you, that's pretty much the highest form of immortality a chemist can achieve. Now, you would think that creating one of the pillars of modern science would be enough for one lifetime, but the story doesn't actually end there. Turns out Mendeleev was a man of many bold ideas, including one that's a whole lot more controversial. So was Mendeleev just a one-hit wonder? Oh, not even close. Turns out, decades before his work on the elements was even fully accepted, he was pushing another really radical idea about something we all use every single day: oil. Yeah, long before we all learned the term fossil fuel, Mendeleev was out there arguing for a theory that turns that entire concept on its head. He got fascinated with where petroleum actually came from and landed on a conclusion that was, and frankly still is, completely different from the mainstream. It's called the Abiogenic theory. You know, we're all taught that oil comes from the compressed remains of ancient life: dinosaurs, plants, plankton. Mendeleev argued for something else entirely. He said oil isn't a fossil fuel at all, but a raw, primordial substance cooked deep inside the earth when it was first formed. So, according to this idea, hydrocarbons are just one of Earth's original building blocks, created under insane pressures deep in the mantle. Then, this primordial oil slowly seeps upward through deep cracks in the Earth's crust. And what about all those biological molecules we find in crude oil? The theory just says they're leftovers from deep Earth microbes that basically snack on the oil as it passes by. And he was absolutely certain about it. In 1877, he wrote, "The capital fact to note is that petroleum was born in the depths of the earth, and it is only there that we must seek its origin." Now, to be clear, this theory is not accepted by most geologists today, but wow, it gives you a stunning glimpse into the mind of a scientist who was never, ever afraid to question everything. It just goes to show you, behind every famous scientific law and every name we memorize, there's a real human story. It's full of competition, incredible insight, and ideas that can still challenge us today. It really makes you wonder, doesn't it? What other hidden stories are just waiting out there for us to find?